Welcome to the video on notes for solving exponential and logarithmic equations. This is an accompaniment to the review worksheet that you're getting today in class. So you may want to watch the video for each problem. Each problem demonstrates a section of the worksheet. So you may want to watch the problem, take some notes on the problem, and then go to the worksheet and do the 4 accompanying problems before going to the next example that I'm demonstrating. So the first thing that we're dealing with is exponential equations. And again, you know that you have an exponential equation when you have a constant to an exponent and the exponent happens to have variables in it. In other words, the exponent is some function of x. Now remember that sometimes you may need to use some rules of exponents in order to combine two things together on a single side of an equation. Also remember that we like to get both sides to have the same base if possible, and if it's not possible, then we need to do some alternate maneuvers with logarithms. So in the first example that we have here, we have two things with a base of 10, and on the right side of the equation we also have a base of 10, but the 10 is in the denominator. So you're going to need to go ahead and on the left side of the equation you're going to have to combine the 10 to the negative 3x times the 10 to the x by adding the exponents, because when we're multiplying like bases we are adding exponents together. So on the other side of the equation, I have a 10 in the denominator, and I'm going to need to rewrite that as a base of 10, so that is 10 to the negative first. That's how it got to be in a denominator. Now, on the left side of the equation, negative 3x plus x we can reduce to negative 2x because they are similar terms. So in the end now, because we have the same base on both sides of the equation, we can go ahead and make the exponents equal as well, because if the bases are equal, then the exponents need to be equal. Finally, divide both sides by negative 2, and that will give you your final answer. In the next example, you will see that you have another exponential equation. We are trying to solve for x, and x happens to be in an exponent. So as with anything in algebra, we need to try to move things away from the variable in order to isolate the variable, and so it will say x equals at the end. So I'm going to go ahead and add 4 to both sides. Which leaves you with 3 times 2 to the x plus 6 equals 21. Remember, you cannot multiply the 3 times the 2 because they do not have like bases, and the 2 has an exponent currently. So instead, you need to divide by 3 to get it away from the 2 to the x plus 6. Now this is an example where clearly you can't get both sides to have a base of 2. 7 is not 2 to the anything power. So this is when you go ahead and you can change the exponential equation into a logarithmic equation. And by that we mean that as a log, this can be rewritten as log base 2 of 7 equals x plus 6. And then go ahead and subtract 6 on both sides. So the x is equal to log base 2 of 7 minus 6. Now remember, the log base 2 of 7 is 1 unit. It is a decimal, and the minus 6 is separate, so you cannot subtract 7 minus 6. That would not make any sense. You can actually leave the answer like that, or you could use the change of base formula in order to get a decimal. So as a decimal, I would need to change the base, and I would say log base 10 of 7 divided by log base 10 of 2. That's how you would do log base 2 of 7. And then you'd get that answer and you would subtract 6. That's how you would go about getting a decimal. In the last equation, you have 3e to the x, and you're probably wondering, well, what the heck is that? Like, what is this e? E is just a constant. It is a button on your calculator. So if you push that button, you'll see what e is equal to. It's kind of like pi. Pi is a number. E is also a number. So again, what we're trying to do is we're trying to solve for x. So we need to move everything away from this e to the x. So I'm going to go ahead and subtract 7 on both sides of the equation. 9 minus 7 is 2. Again, goal is to get e to the x by itself, so divide both sides by 3. And then you're trying to solve for x, but x isn't an exponent. So when that happens, you can go ahead and turn this into a logarithmic equation. But I'm going to give you a little helpful tip here. There is a button called ln on your calculator. And as we talked about before, ln is log base e. So if I go ahead and I turn this into ln, that's log base e of 2/3 is equal to x. That is essentially the answer. You could put that now into your calculator and get a decimal answer, or you could leave it alone. Okay, so now we have some more problems here. These are now logarithmic equations. You can see because they all have logs in them. So there's two possibilities that you have here. You may want to try to get a log with a base on the left and a log with a base on the right. And as long as they're the same log, the things that sit next to the logs are also equal. Or, in the case of the first one, you have a log base 3 on the left and no log base 3 on the right. There's only a 2 on the right. So because you don't have the same log on both sides of the equation, you can go ahead and turn this into an exponential function. So to take this log and write it as an exponential function, the base is 3, the exponent is 2, and the answer is 25 minus x squared. So that's what it looks like as an exponential equation. Of course, 3 squared is 9. And then we can solve this equation by square rooting. I'm going to go ahead and subtract 25 on both sides. And I get negative 16 equals negative x squared. Divide both sides by negative 1. So x squared equals 16. And square root both sides, and you get x equals plus or minus the square root of 16, which is plus or minus 4. Sometimes, when you go to solve a logarithmic equation, you need to use the properties of logs to combine them into a single log. That's what we see in the next example. You have two ln's being subtracted. So in order to condense them to a single log, to change the subtraction symbol into a division between those two things. Now it's a single log. Again, remember that ln is log base e. So if we translated that into log base e, you would see that because we don't have log base e on both sides of the equation, you can go ahead and turn this into an exponential function. So as an exponential function, the base is e, the exponent is 5, and the answer is 4x plus 1 over 3. E to the 5th is just a number. You can calculate that with your calculator. And we're trying to solve for x, so we need to undo the right side of the equation. So I'm going to go ahead and multiply both sides by 3. I'm going to subtract 1 on both sides. And divide both sides by 4. So x equals 3e to the 5th minus 1 all over 4. And again, you could leave it like that, or you could get the decimal equivalent of it. In the next problem, I can see that I have ln's on both sides of the equation, and those are log base e's on both sides of the equation. But I see that on the left side, I have 2 ln's, and I want to condense them to a single ln. So when you have a subtraction between 2 logs, you can go ahead and change it into a single log by making it a division symbol. So that would be ln of 4 minus 3x over 7x. Now that I have an ln on the left and an ln on the right, I can see that because those two things are equal, then the two things that sit next to it are also equal. To solve this equation, I can go ahead and multiply both sides by 7x. Add 3x to both sides. And divide both sides by 80. In the next example, again, I can see that there's an addition sign between 2 logs. I need to condense them into a single log, and I condense a addition symbol by multiplying these two things together. So I end up with log of x squared minus 3x. In this case, I don't have a log on both sides of the equation, so I need to go ahead and change this over into an exponential function. The base is 10, the exponent is a 1, and the answer is x squared minus 3x. This makes a quadratic equation which I now need to get equal to 0, so I'm going to go ahead and subtract 10 on both sides. And I'm going to factor and solve. So two numbers that multiply to make negative 10, add to make negative 3. That would be negative 5 and positive 2. Therefore, x minus 5 equals 0. So x is 5. And x plus 2 equals 0. So x is negative 2. Don't forget that you're actually supposed to check all of your answers. I wasn't doing so in the previous problems because I kind of knew that they weren't an issue. But now we need to point out that there is an issue here. If I put 5 in for x, everything is okay. But the problem is when I put in negative 2 for x, we have an issue right here. Because that would say log base 10 of negative 2. And you can't have a negative sitting next to a log ever. 10 to the nothing power ever gives you -2 for an answer. So therefore, this is called an extraneous solution, and I can cross out the -2. And the only answer would be the 5, because it's the only one that works. In our final problem, I can see that the right side of the equation, again, has 2 separate logs. So we need to go ahead and combine those 2 separate logs. And we combine them because it's an addition with a multiplication. So I'm going to do 2 times 3x minus 4. Which gives you log of 6x minus 8 when you distribute the 2. The other issue is that we have on the left 2 log, and on the right I have only log. So somehow I need to fix it so it just says log of something equals and log of something equals. So I need to take this 2, and you might remember the rule that says the 2 got to the front because it was actually originally an exponent. Remember we said when there's an exponent on a log, it can drop to the front? Well, if it's in the front, it can go back to an exponent. So I need to go ahead and do that so that I no longer have the 2 in the front. Put it back as an exponent. Now both sides have a single log. So I can do x squared equals 6x minus 8. I'm going to go ahead and subtract the 6x and add the 8. And that makes x squared minus 6x plus 8 equals 0. You can now factor and solve. So x equals 4 or x equals 2. If you substitute 4 and 2 back into the equation, both of them work. So there are 2 answers. Okay, now it's your turn. Make sure that you get the worksheet done during class today.